Hello. Today we are going to be discussing an entry-level concept in the area of the time value of money, TVM, using timelines. Now, a timeline is something that you should get in the practice of setting up and using even when working out simple problems. The reason being is setting up the timeline gives you a visualization of what is happening with the cash flows associated with a particular problem. And if you get in the habit of doing that with simple problems, then you will be able to use this concept when working out a complex time value money problem. Again, being able to visualize the cash flows and when they occur is a key component of being able to successfully solve any time value money problem. So let's give you an example of when you might face a very complex problem. Suppose you were saving money for one of your kids for college. So you've got one timeline associated with the time your offspring is in college. It could be 4 years. Maybe your kid's a slower learner, 6 or 7 years. Whatever, you have to cover those payments. So college tuition tends to grow at some rate unless you are in a situation where you have a fixed payment for a 4-year period as an incentive to encourage timely completion. The other part of the problem is, okay, now that you know how much you need to have to finance the education, how much are you going to have to save over time to get there, assuming you've got 4 or 5 years until your kids start school? It may be that you already have some money, maybe not. So this is a complex problem that deals with both lump sums of present values, payments to accumulate a future value, and the payments necessary to fund a 4 or 5 year college education. Boy, that can be very hard to solve if you don't set up timelines. We are not going to do a complex one. We're going to do a simple one and show you the concepts of how to set one up, and then you should be able to set up timelines for pretty much any problem. So let's go to the next slide we've got set up here. Setting up a timeline. Well, a timeline is, first and foremost, a line. So let's say we start at some point here and continue for some number of periods. Okay? So we have a line. We typically have tick marks, sometimes called hash marks, tick marks, that indicate a particular time period. So something on the order of this. So those are our tick marks or hash marks. On top of those tick marks, we indicate the time period. We always start at time 0. Time 0 represents today, or time 0 represents a reference point for a present value. So there's time 0, 1, 2, 3, 4, 5, and so on. Now, there's nothing magic about these time periods, nothing particular. This could be 5 years, it could be 5 quarters, it could be 5 months, it could be 5 days. It's simply whatever the number of period or whatever the periods are that you're looking at for your problem. So if you're looking at a mortgage problem, typically you're talking about monthly. If you're looking at an annuity problem for college tuition, you're probably looking at an annual problem, right, for those payments, but maybe a monthly problem for making savings into an account that will fund tuition. If you're working a problem with many time periods, obviously you don't want to write 1, 2, 3, 4 all the way out to 360 if you're doing a 30-year monthly mortgage problem, right? So typically what you would do in that case is something like this. So I'm going to erase part of this. So maybe you set up a couple of years. You indicate that there's a a bit of a break going on here. Dot, dot, dot. And then you complete the timeline. Something like this. Sorry. That. Where this might be, let me add my little squiggly. This might be in. Since I'm using a monthly problem, I keep getting the lasso effect here. Let's undo that. This could be 360, for example. And so you would have your mortgage payment out for 360 years. You wouldn't want to do a timeline for that long. So this is one way to make it tractable, or make it manageable, I should say. Let's clear this up. We'll erase this. Anyway, probably easier just to reset the whole timeline. So, setting up our timeline. Here's an example, 4 years. So this is a 4-year example. Okay. Now, we have the time periods above the tick marks. Below the tick marks is where you have the cash flows. So you will have cash flow 0, cash flow 1, cash flow 2, cash flow 3, cash flow 4, and so on. I'm going to add to the timeline here. We'll carry this out in periods. And then we have cash flow period N. Like that. So, we said we're going to do a 4-year problem. We did, but I wanted to show you how you would extend the cash flows for period N, or for N periods in a problem. So that's pretty much how you would set that up. Now we've got almost everything we need. The last thing we need is R, or I if you're using interest rates. So basically R represents the rate of interest, the rate of growth, a required rate of return, yield to maturity if you're looking for that. Basically, it simply represents the periodic rate that applies to this problem. And again, it could be a growth rate, such as tuition, it could be an inflation rate, it could be an investment rate, it could be a required rate of return. Whatever the rate is, it would go between the tick marks. Okay, let's do an example with actual cash flows and show you how you would set that up. So the example we're going to do is a bond value. This particular bond pays an annual coupon of 8%. It's got a $1,000 par value or face value, And rates for similar risk bonds are 10%. Now, there's one bit of information we left out here. I'm going to add 4 years to maturity. So let's say you buy this bond. You buy this bond today for whatever its market price is. What you get in return would be 4 coupon payments of 8%, and you would also get the $1,000 par value. So 8% coupon on a $1,000 par value bond, 8% times 1,000, that is $80. So you're going to receive 4 payments of $80 and 1 payment of $1,000. Rates for similar risk bonds is 10%. So let's set this thing up on a timeline and solve it. Bond cash flow. So we're going to use, again, I'm using the grid background here so we can try to get straight lines. Okay, this is a 4-year bond, so I need tick mark for time 0, year 1, year 2, 3, 4. Apparently I carried this out a little too far, but we can easily take care of that. We place the periods above, so this is time 0. This is time period 1, 2, 3, and 4. Now we need to add the cash flows. If we buy the bond today, we've already established that we get an $80 per year coupon payment for 4 years. So let's add that. We get $80 here, $80 here, $80 here, $80 here. Now all this assumes we buy the bond today and hold it until it matures in 4 years. Now at the end of 4 years, we also get this $1,000 back. Rates on current rates on similar risk bonds we've established to be, well, let's try to make this a little bit cleaner. %. Now, if you know anything about bond valuation, you know that as rates increase, bond values fall, and vice versa. This bond pays an 8% coupon. Since the time it was originally issued, rates on similar risk bonds have gone up to 10%. So we know automatically that this bond will be selling at a discount. In other words, its current market price or its current market value should be something less than $1,000. And that is what we will try to establish as we look for the bond value today. Okay, we can call this B0 or present value. We're basically looking for the present value of this cash flow stream. So what we have here, and I'm not going to spend a lot of time going through the different methods of computing this. I'm just going to show you, or as a reminder, of 2 more time value money concepts while we're looking at this. First of all, we have this series of payments right here. See this? 4 payments of $80. So anytime you have a series of payments that are identical, you have what's called an annuity. So we have tools, we have either formulas or you can use tables in the back of any finance book to determine the present value of that annuity. That's one time value money problem. The second one is we have this $1,000 out here as a future value. That is a lump sum. So we would find the present value of the $1,000. We would find the present value of the $80 annuity. We would add those 2 things together, and that would give us the present value of those cash flow streams, or what the value of the bond should be. Okay, let's go now and let's find the answer to this. So I'm going to use a financial calculator. You can use a financial calculator, you can use a formula method, whatever you want to do is fine with me. So we're going to use a financial calculator. I am using the Hewlett-Packard, I'm using the Texas Instruments BA2 Plus Professional. And so it's going to want some inputs. We are going to use an N of 4, right? Maybe this will better, N of 4. The interest rate per year that we're going to be using is 10. The payment is going to be 80. Future value is 1,000. Now, this is very easy. I know exactly where to place these things because I've set up my timeline to show the cash flows. I know I've got a payment stream of 80. I see that on the timeline. Future value of 1,000. And then what we will do is we will simply compute present value, and you should get a negative 936.60. Why the negative? Because financial calculator, same as a spreadsheet actually, keeps track of the direction of your cash flows. So this is another very important time value money concept. If you are looking at an investment that's going to give inflows to you of 80 and 100, or 80 per year for 4 years and 1,000 in 4 years, those are inflows to you. Those would be positives. You have to pay to get that stream. You would pay $936.60. So let's go back now to our timeline, and we can add that amount right here. Was it 60? I forget. Let's go back and look. Yes, 60. So this is a very simple example, an applied example. Bond valuation, easy for me to say, right? Showing you how to set up your timeline, showing you how to place the cash flows, and then simply going to your timeline, seeing what those cash flows are. You can very easily plug into your financial calculator to solve. That is all for now. Thank you very much.